So in this lecture we will understand about superposition theorem. We'll start with a statement of a superposition theorem, then the rules that we have to take care while we apply superposition theorems, and then in last we will solve one example so that you will get a clarity how to apply the superposition theorem in order to solve any electrical network. This is the statement of superposition theorem. Now, if we go through the statement, so in order to find the response in any linear circuit at any point, if you are having more than one sources, so you can simply calculate by summing the effect of each sources considered separately and all the other sources at that time you have to make inoperative. So in a simple language, if you are having more than one source at a time, if you are interested in finding the response, so response may be exactly what? So you may be asked for current which is flowing through that particular element or voltage across the any element. So in order to find the responses in a circuit when you are having multiple sources, so what you can do is you can make other sources inoperative and then you consider at a time one source, you find out the responses. And then let's say if you are having three sources, so you just consider one source at a time, you make disable two other sources, find the response, do it second time and third time for second and third sources. While you are considering second source, so make first and third inoperative. While you are considering third source, so make first and second source are inoperative. Okay, so how to make sources inoperative? So firstly, let's say if you are having a voltage source V, so here you have to simply make this voltage to 0 volt. So how you can do this? So if you short this voltage source, then and then it is possible. Reducing the voltage to 0, it is only possible with a simple wire who is having 0 resistor, and 0 resistance means nothing but short circuit. So you can simply replace with short circuit any voltage source. And if you have current sources like this, so in order to make this current source inoperative, you have to reduce current to 0. To do so, you have to increase the resistance to infinite, and this is only possible when you are having a circuits in which you are having open circuits. So at that time the voltage across this will be, when your current is 0, okay, so at that time the voltage across the open circuit will be same which will be offered by the other part of the circuits. But in short, while you have a voltage source, you have to short it. While you have current source, you have to open it. All right, so this is what the superposition theorem all about. Now let's understand up with solution of this example. Now if you just observe this particularly circuit, so here we have two sources, source number 1 and source number 2. The source number 1 is current source who is having 0.5 ampere amplitude, and second source is a voltage source who is having 80 millivolt voltage. Now I am interested in finding the response through this, so this is the response I have to find out. Now if I am looking for the current which is flowing through this branch, and if I am having multiple sources, multiple maybe sources which is greater than 1, in this circuits we are having two sources. So what we have to do is we have to consider one source at a time, and we have to make other sources inoperative. So I am doing with making first source only. So my first source is there and my second source is inoperative. Okay, so if I redraw these circuits, so this will be like 0.1 ohm and here I will have this current source. Now in source number 2, this is 0.3 ohm, and here what I have to do with this voltage source, I have to short it. Okay, so this is my circuit number 1. I am looking for current, what it is. So, and then I have to apply all the basic theorems like current division rule, and then I can work out the current through this particular branch. In the second case, I have to make source number 1 to inoperative and source number 2 in a function. Okay, alright, so here I have to deal with this like this. So I have to open circuit this current source as we have discussed, and here it is like 0.3 ohm and 80 millivolt. Alright, so this will be the another circuits. This is the first case, this is the second case. So first task is to consider one source, at the same time disable or make other sources inoperative. Say for example, here I am making source number 2 inoperative and source number 1 is only there in the circuits, and in the second case only voltage source is there and current source I have opened it. Now in order to find the current, so here if I just focus on this particular part, so here I can apply current division rule. So current will flow here and here. In order to find current here, so let's say this is I, so this I can be given as, if I apply a current division rule, so voltage in the other branches, resistance in the other branches, which is 0.3, and sum of 2 resistor multiply with overall current. And what was the overall current? 0.5 amps. So into 0.5 ampere. So this is nothing but 3/4 into 0.5 ampere. So it would be around 0.2 ampere. Okay, so this is the I1 current. Okay, and this I1 is in the opposite direction to the actual current which we are looking for. That you should you must keep in your mind. Okay, all right. Is it 0.5? Let me just let's say 3/4 into 0.5. Let me recalculate the same. So it's 3/4 into 0.5. Okay, yeah, so there is one correction. This ampere will be 0.375 ampere. You can calculate by using this. Now here we have to find out the current. Okay, now as we have this source, so current will flow like this. So what will be the I? So these two resistors 0.1 and 0.3 both are in series, so the overall resistor will be 0.1 plus 0.3. And what is the voltage? Which is 80 millivolt, right? So 80 millivolt. So 80 millivolt, if I divide with 0.4 ohm, so what will be the overall current? So my overall current will be 80 millivolt divided by 0.4, so which will gives me 0.2 ampere. So this 0.2 ampere will flow in this direction, and this current, my I1, this is my I1, so this current will flow in the opposite direction, 0.375 ampere. So what superposition theorem states? That firstly I have to find out the current which is caused by the individual sources. So the current due to this 0.5 ampere means source number 1 is 0.375 and it is in the opposite direction to the mentioned direction of current, and due to the other sources which is of 80 millivolt, the current is 0.2. Now if I find the net current in this direction, so I is 0.2 ampere minus 0.375 ampere. So this will be, so answer will be minus 0.175 ampere. Okay, so this is my overall current. So this answer is 0.175 ampere, and then answer will be negative. Okay, so in this way you can apply a superposition theorem, and you can simplify any circuits. But the key idea is you make one source active at a time, you disable all the other sources, you target your particular element in which you are looking for the current or voltage, and you do all the calculations. You apply KCL, KVL, node analysis, mesh analysis, whichever things you are required, and then you find out the individual responses, and then in last you consider the direction. Sometimes you may have the same direction, so at that time you have to add the current. If you are getting the opposite direction like the same which we get here, you have to subtract it. But in short, after doing all those exercises, you will get the final response, and this is the response when you are having two sources which are acting at the same time on the circuits. So if you connect everything like this, so overall net current which you will find in the circuit is minus 0.175 ampere. Okay, so in this way you can apply the superposition theorems, and you can find out the response.